Welcome to Maths with EJD. In this video, I'll be solving the structured problem displayed as follows. This, as you can see right on the screen, I got a feedback that the questions, the way I've been displaying them, have not been quite clear. I apologize for that. But I mean, to make up for that, you can check the description box on YouTube, especially to see the questions I was solving in those places. But starting from here, I found a nice way to display this so everybody can see it very clearly before we start solving. So this is the question. If the class marks in a frequency distribution of the times measured to the nearest second, taken to answer a quiz question are 128, 137, 146, 155, 164, 173, and 182 seconds, find one, the class interval size, two, the class boundary, three, the class limits. Then B, the table below shows the relationship between X and Y at various values. So you have X and Y, pairs of 54.3 against 61.2, 61.8, 49.5, 72.4, 37.6, 88.7, 28.4, 118.6, 19.2, and 194.0, 10.1. So that's what we have. And let's go for it. The first question is that if the class marks in a frequency distribution of times measured, so we have class marks. So that's A now. A, given class marks 128, 137, 146, 155, 164, and 173. Okay, and 182, sorry. 182, 173, and 182. So given these class marks now, the first question we have is to find the class interval size. One, to find the class interval size. Okay. Now, usually, right, the class interval size, so these are class marks. It's more like, okay, let me just do a kind of aside. Normally, I think there's a problem we did earlier that has like 3 to 7, then 8 to 3, 4, 5, 6, 7, then 8, 9, 10, 11, so 8 to 12, and 13 to 17, and so on and so forth. So imagine this is what we had, right? So this was X, and the class mark X would be 3 plus 7, 10. Okay. 10 divided by 2, the class mark was 5. 8 plus 12, 20 divided by 2, the class mark was 10. Then 13 minus 17. 13 plus 17, 30 divided by 2, 15. So you can see the class mark was 15. So you see that the differences between the class marks will be 10 minus 5, 5. 15 minus 10 is also 5. But guess what? The actual class interval is not 5. It's actually 7 minus 3, which is 4. So it means that the class interval is actually the difference between the class marks minus 1. So it's more like if you have class mark x2 minus x1, then you have to subtract 1 from it to get the class size. So if that makes sense, then we can use that same idea to answer this question. So we want to find the class interval size. So you can already see that if this is if this is x1, x2, x3, x4, x5, x6, and x7. We don't need everything because the pattern is clear. You can already see that x2 minus x1. Okay, let me revert to this. You can already see that x2 minus x1 is equal to uh 137 minus 128, and that is equal to 9. The same is true for, so this is same for x3 minus x2 all the way down to x7 minus x6. It's 9 all the way. So if that is anything to go by, right? So this is the interval between the class marks, which is like this 5 we have got now. But the actual class interval size is going to be 1 less 9, right? So we can say, therefore, the class interval, the class interval size is something like you can say xn plus 1 minus xn minus 1. Okay. So if you like, you can call that, let's call that class interval size. So that is CIS is more like something like x2 minus x1, or anything you pick. It can be x3 minus x2, x4 minus x3, anyhow you want it, minus 1 now. So the class interval size now is x2, which is 137, minus x1, which is 128, minus 1. So class interval size is simply 8. So the class interval size is 8. Just like, though the difference between the class marks here is 5, but the actual class interval size is now 7 minus 3, and that is 4, right? So you consider as 5 minus 1, which is 4. Then 12 minus 8 also is 4. So if you can follow that kind of argument, then it will make sense to say that the class interval size is actually 8. Okay? So I had to do this to give a kind of background to what I'm doing now. Now let's go for the next part of the question. Now we have found the class interval size, which is 8, though the difference between the class marks is 9. So the difference between the class marks minus 1 gives you the class interval size. If you ask me, that's what I think. Maybe it may be differently explained in another context, but to my mind, that is what I think it should be, especially following questions we had done before. Now let's talk about the class boundary. In fact, I think if you ask me, right, class boundary, class limits should come before class boundary. So if you indulge me, I'll go to class limits first and say number 3 to find the class limits. Because once you know the class limit, you can find the class boundary. So we can say to find the class limits, I believe that should come before the boundaries. Now you already know you have 128 plus 9, that's 137 plus 9, 146 plus 9, 155, I believe. Yeah. Plus 9, 164 plus 9, 173 plus 9, 182, and that's how far it goes. Now, we need the class limits. That means, these things are class mid mark, or what is that called now? Yeah, class mark rather. So this class mark is actually at the center of the interval. Okay, it's actually at the center of the interval. So if that is the case, okay, imagine here now that the class mark here is 5 within interval 3 to 7. So you can see that what we have found here as the interval, as the class interval size is 4. So for you to get the lower limits, it means you divide this 4 into 2 by 2. So if you divide it by 2, you get 2. So 5 minus 2, you get 3. Then 7 minus 2, I mean, 5 this mid mark, 5 minus 2, you get 3. 5 plus 2, you get 7. So same here. 8, 10 minus 2, you get 8. 10 plus 2, you get this 12. So if that is the case too, it means that we need to find the spread is equal to the right and left. So if you like, you can allow me to say the spread of each class is CIS, that's class interval size, which is equal to 8 over 2 equals 4. So the spread of each class is 4 units, 4 units to the right and left, of the class mark, if you know what I mean. So it's 4 units to the right and left of the class mark. Okay. So it means the class interval size you got, which is 8 now, divided by 2, you get 4. So in that case, if you subtract, how do I put this now? So if you subtract 4 from this, so this 4, so you have 4. So if you subtract 4 from this, you get 124. Okay. Then if you add 4 to it, you get 132. Okay. And that makes sense because you now see that 124 plus 132 would be 256. If you now divide that by 2, you get actually the 128 that is in the center. So that makes a lot of sense. That's what I like to think about that. So in here now, you just have okay. I guess I want to change the color so that this can go. Okay. Um, so this is okay, I think this is fine. So subtract 4, you get the lower limit. That's 124. Add 4, you get 132. Okay. Then here, subtract 4, you get 133. Add 4, you get 141. So 137 lies in the middle of that. Because if you add 133 plus 141, that'll be 264. Right? That's actually 274, 274. And that's 137 if you add the 2 and divide by 2. Okay. So add 4. So this is minus 4 and this is plus 4. And that's what we are doing all the way down. So this minus 4, you get 142 plus 4, you get 150. Okay. Then this minus 4, you get 151. This plus 4, you get 159. So again, this minus 4, you get 160. This plus 4, you get 168. Then this minus 4, you get 169, right? 169. And this plus 4, you get 177. And lastly, you get this minus 4, that's 178, I believe. Yeah. Then add 4, that's 186. So the class limits now. So you can say, therefore, the second, okay, I'm doing the third one because I believe the class boundary can follow the class limits. So we can answer, therefore, the class limits are, the class limits are, okay, I'll just put, so it will be a collection of lower limits and upper limits. Or let me put it this way. So there are collections of lower limits by upper limits. Okay. And that will simply be equal to all the pairs we have. So that's 124, 132, 124, 132. Then next is 133, 141, 133, 141. Next, you have 142, 150, 142, 150. Next, you have 151, 159, 151, 159. Then you have 160, 168, 160, 168. Then you have 169, 177, 169, 177. And lastly, you have 178, 186, 178, 186. Now you can see, just like I said before, the class interval size is actually, when you subtract this now, the difference between these two is 134, 132 minus 124, that's 8. Same here. If you add 8 to this, you get 141. So that's why I feel that the class interval size, I feel this question it can be ambiguous. So, but based on my understanding, this is what I think it should actually be. So, in case you think it should be something else, please let me know in the comments. Or if you can interact with me on other platforms, I'll be very glad. Okay. So with this now it's more like that's why I call this group data retrieval and regression. So it looks like for me, we have retrieved the original grouped data from which the class marks were derived. So now we can now get the boundary, right? So the second part which I skipped to get here because you can't get boundary without limits. That's why I had to skip that first. So we'll go for, so we can now, so I'm going back to 2 now. I can now say to find 2 now, to find the class boundaries, the class boundaries, to find the class boundaries. Just like we know, right? Normally you have 124 to 132. That's like the X now. You have 133 plus 8, that's 141. Then you have 142 plus 4. I mean, plus 8, that's 150. Yeah, that's what we really have. Then you have 151 to 159. Then you have 160 to 168. That's what we really have. Then you have 169 to 177, I believe. Yeah. Then 178 to 186. Okay. That's what we have. But we need the class boundaries. And how do we do boundaries, right? So the boundary, to get boundaries, this is how we go. You add these two and divide by 2. That's how you get the boundaries. So that means you have 132 plus 133 divided by 2. That will be 132.5. So that simply means that the uh so okay, if I can actually call this boundaries now, I can say boundaries. So if you want to call these boundaries now, so that means that we have something like this. So the boundary can also be upper and lower boundary. So let me do it in the sense of upper, okay, lower first, right? Just like we did the limits. So we have uh lower lower boundary. Or let me put it this way. What's the best way now? Okay, boundaries. Let me just say boundaries, lower comma upper. Okay, I think it's fine. Lower comma upper. So this 132.5 we got now is actually the upper boundary of this class and then the lower boundary of the next class. So this 132.5 now. So if we want to fix that up, then we can say and apps. Okay, we can even see the pattern, right? So the lower boundary for the upper boundary for the first class is 132.5, but it is the lower boundary for the next class 132.5, comma. So for this next one, it will be 141.5. Okay, 141.5 because that'll be 141 plus 42. Then this is gonna be 150.5, the lower boundary for this, and then the upper boundary will be 150. Okay, I guess yeah. Okay, yeah. Okay. So the upper boundary for this, which is 141.5, we can carry it down here. So 141.5 by 150.5 because that's the next thing. So that other one now will now be 150.5, lower boundary for this. So it comes before this, just like 132.5 comes before and 141.5 comes before this by 159.5. Then next, the upper boundary in the first place is going to be lower boundary for the next one. For the next class, that's 159.5 by 168.5. So lower upper like that. Then again here, the upper boundary in this class becomes the lower boundary for the next. So that's 168.5 by 177.5. And lastly, we have 177.5 by 186.5. Though we can't see any other class after that, but we can actually know that that's how that works. So the lower boundary here is actually the upper boundary in this case, 132.5. So we can know that this is actually 123.5. It's so to the lower boundary, subtract 0.5 from the lower limit, you get the lower boundary, and add 0.5 to the upper boundary, you get the to the upper limit, you get the upper boundary. So this is actually what we want. These are the boundaries now that we actually want. Okay. Or better still, I can do this. So this is the upper, these are the boundaries, both lower and upper boundaries. And with that, I believe the first question we have done justice to it. I know that maybe the approach may be different in other contexts, but I've only interpreted this based on what I think it should really be. Okay, so let's go on to the second part of the question, which says the table below shows the relationship between x and y at at various values. So we need so the first part is of that is write the equation connecting x and y and estimate y when x is 100. So basically we need to do a regression thing right there. Uh, so we can go for B now. B, to write the equation, connecting X and Y, generally, generally, we have, regression, right? We have, um, how do I put this now? Okay, I can say Y is equal to beta naught plus beta 1 X. Then beta 1 now has a special formula. So we now, of course, beta naught, of course, is okay, I mean, I can talk about that. This is actually the intercept. This is the intercept, and this is the slope. And like we know, the intercept gives us if you're talking about salary, if for instance, Y is about salary, so, and maybe X is the amount of hours you spent working, you know, something like that. In that, being beta not means that even if, before you start working at all, you have already earned, once you show up at work, you have already earned beta not. That's like minimum wage or something like that. Um, you know, for want of better description. So to get the slope, right? Of course, why is it just like we already know? Maybe because I already taught that in the statistics playlist. So this is the dependent variable, dependent variable. So this variable y depends on x, which is the independent variable. Okay, like that. So since we want to, so we have the values given in the table are the values of x and y. So we have those. So we want to use that to get an equation like this. And the format, the idea, the way to go about that is this, that beta one has an expression, and it is simply this. To get beta one, that's n summation xy. It's looking a bit like how to get uh, correlation coefficient. That's the Pearson correlation coefficient. But then there's a bit difference in the denominator. So this summation x, summation y divided by n summation x squared minus summation x all squared. So the difference is that in Spearman correlation, you had to take square root of this multiplied by n summation x y squared minus summation y all squared. That's the only difference. But here, this is how beta one is obtained. Then how do we get beta naught? So we know that from beta naught, right, we can actually have from the formula, right, you have y equals beta naught plus beta 1 x. So, but you have obtained, this is formula to obtain beta 1. So we also need beta naught. That's another part. We need those two things to be able to get the equation. But to do that, right, we need to find we need to find the average of this thing. So it's more like we have summation y over say n. N is the number of variables equals beta naught plus. Of course, if we find the average of constant, it's always that. Then summation y divided by n. So that means you actually have something like y bar equals beta naught plus beta 1. Oh, sorry, this is x. This is actually x. So this is x. So that's beta 1 x bar. So, and what we need now is beta naught. You would have found b1 from here, right? So so to get this now, so we now have y bar minus beta naught equals beta 1 x bar. Okay. So we can divide both. Oh, okay. No. We need beta naught actually. Beta naught is what we need. Apologies. So we need beta naught. Since it's beta naught we need, so we can have y bar minus beta 1 x bar equals beta naught. And we'd have got beta naught from up there. So we have beta naught equals y bar, the average of y, minus beta 1 x bar. So with this now, we find beta naught. And once you find beta naught and beta 1, you're good to go. Okay? Once you find beta 1 and beta naught, you're good to go. So you just substitute into the equation and keep going. So we have all the formulas we need. So let's set up our table the way it should be. So we go back to the original data we were given. Don't forget, it's in that place, 54.3, 61.2, and so on and so forth. So I'll just come and set up the table as required. Let me go X. Okay. Let me use this now. So X, Y. So let's set all those up. XY, right? So the first one is 54.3 against 61.2. Next, we have 61.8 against 49.5. Then we have 72.4 against 37.6. Then we have to really be careful because mistakes are easy here. 88.7 by 28.4. And then we have 118.6 by 19.2. And lastly, we have 194.0 against 10.1. So those are the values of X and Y corresponding. We have all that. So okay, I mean, you have to really check to be sure everything is in order. Check to be sure everything is in order. So every step you take, you have to be conscious of time, right? But at the same time, you don't want to make mistake because any mistake can actually set you back a lot. So we have 54.3. Okay, let's check with one at the top. 54.3, 61.2. Yeah, 61.8, 49.5. Okay, I think it's a long way off. What can we do? Yeah, so I think it's fine actually. 54.3, 61.2, 61.8, 49.5, 72.4, 37.6, 88.7, 28.4, 118.6, 194, 118.6, 19.2, 194.0, 10.0. Okay, we have that. Then this is the main work now. So we need the summation of X and summation of Y. We can easily find that from what we already have. But then we need summation of X squared and then summation of XY. So we need X squared and XY basically now. So in that case, we need X squared. We need X squared. And then we need XY. Okay. So once we can find this, then we have everything we need to get the equation. So let's go now. So like I keep warning, be sure that you have to be sure that the calculator you'll be using is a calculator you are already used to. Don't borrow a calculator. Don't collect somebody else's calculator and take it to the exam, or you can get into trouble very easily. So make sure you have a calculator and a table you've been using that you have mastered, you have practiced a lot with it. So anytime you're writing a statistics exam, so you don't get thrown off balance easily. So let's go for X squared, right? That's 54.3. And in computing all this, you have to be very careful. 54.3 raised to power 2. That is 2948.49. 2948.49. Okay, 2948.49. Then we have 61.8. 61.8 raised to power 2. That is 3819.24. Then we have 72.4. 72.4 raised to power 2. That is 5241.76. Then we have 88.7. 88.7 raised to power 2. That is 7867.69. 7867.69. And we have 118.6. 118.6 raised to power 2. That is plenty. That's 14065.96, right? 14065.96. Then we have 194 that's 194.0 raised to power 2. That's 37636. 37636. Okay, that's done. We move on to the next one, which is xy. Now we are doing all of this based on the formula we need to use. We need the summation of xy. So that means we need to multiply x and y and sum up all of that. We need summation of all of x. We already have x. We need summation of all of y. We already have y. Then we need the summation of x squared. That is what we just found. Then we need the summation of xy. Summation of x is already there. So summation of xy is next. So let's go carefully. Let's go very carefully to see how that works. Here now, we have 54.3 times 61.2. 54.3 times 61.2. That is 3323.16. Next is 61.8. 61.8 times 49.5. 69.8 times 49.5. 69.8 times 49.5, that is 3059. 3059.1. Then we have 72.4. 72.4 times 37.6. 37.6. That is 2722.24. And then we have 88.7. 88.7 times 28.4. 88.7 times 28.4. I already wrote 38.4, so you have to be very careful. 88.7 times 28.4 is 2519.08. Then we have 118.6. 118.6 times 19.2. 118.6 times 19.8. That is 2277.12. And lastly, we have 194 times 10.1. 194 times 10.1. That is 1959.4. Now we have everything out there. So we now need the summations. So summation of x, what would it be, for instance? So that means we are adding all this now. Let's go carefully again. So that's 54.3. Now, if you can avoid this kind of question, if you have easier questions that won't require all this kind of trouble, you should by all means avoid it. So if you have other questions you can answer very easily without this kind of stress, please go for those. Or if you don't have any option, then you can do this. And then you have to be really patient. Then you have to double check every step. And while at it, you also don't want to make mistakes. So I mean, it can be really a task. So you want to go in when you're in the right frame of mind. So I want to check now 54.3 plus 61.8 plus 72.4 plus 88.7 plus 118.6 plus 194.0. So that is 589.8. 589.8. So we also need summation of y. So let's do summation of y also carefully. 61.2 plus 49.5 plus 37.6 plus 28.4 plus 19.2 plus 10.1. Okay, I mean, I already made a mistake there. I put 1% 0.1 instead of 10.1. So you have to keep checking. 61.2, 49.5, 37.6, 28.4. Make sure you don't press minus for plus. That can cause trouble. 19.2, 10.1. And everything is 206 for that. Then we come to summation of x squared, which is also necessary. Now the numbers are bigger, so you need bigger carefulness, so to speak. So we have 2948.49, 2948.49 plus 3819.24 plus 5241.76 plus 7867.69 plus 140.65.96. That's 96, so you have to be careful. Then 376.36. 376.36. Now that I've done that, I want to check again. 2948.49, yes. 3819.24, yes, plus 5241.76 plus 7867.69 plus 14065.96 plus 37636. Good. So the answer is 71579.14. So lastly, we need summation of x, y. So that's all this now. Need to add up all of this. So again, we go carefully. 3323.16 plus 3059.1 plus 2722.24 plus 2519.08 plus 2277.12 plus 1959.4. Let's do that again. 3323.16 plus 3059.1 plus 2722.24 plus 2519.08 plus 2277.12 plus 1959.4. Okay, so that would be 15860.1. All right, so this is a kind of breakthrough that if you can do this carefully enough and get all the answers out, that's you have a kind of breakthrough already. But then that's not the end of the trouble. So we now say, therefore, B1, you remember? B1 is what we are looking for. That's n summation x y minus summation x summation y divided by n summation x squared minus summation x all squared. That's what we are in for, so that we now have beta 1 to be, of course, n is the pair of points, the pair of points we have. That's 1, 2, 3, 4, 5, 6. So we have 6 right there. That's what n is. Is that what we have in the beginning also? So hope I've not mixed things up. 1, 2, 3, 4, 5, 6. Okay, we have 6 actually. So n is 6 is correct. So we have now that this is 6 times summation xy is 15860.1. 15860.1, like that, minus summation x. Summation x is 589.8. 589.8. Summation x, 589.8. Summation y, 206. Okay. Then divided by n again, 6. Summation x squared is 71579.14. 71579.14. Yeah, 71579.14. Then minus summation x all squared. Summation x is 589.8. 589.8 all squared. So this is another level of breakthrough if you can do all this without mixing anything up. Okay? That's another level. So you now go again. We have beta 1 is, so we try to do these things neatly again. So we have 6 times 15860.1. 15860.1 multiplied by 6. That is 95160.6 minus, so 589.8 times 206. 589.8 times 206. That is 121498.8. So divided by now 6 times 715. 6 times 715. 79.14. Okay, that is 429474.84 minus, is that correct? 6 times 71579.14. Okay, that's 429474.84. Then say 589.8 raised to power 2. 589.8 raised to power 2. That is 347864.04. Is that okay? 589.8. Yeah. So that's another breakthrough again. So we keep moving. So we go to the next level. So we have 951. 60.6. Sometimes if you're in a hurry, if you have a powerful calculator, you can put everything at once. Like you already know. That's why you have to get used to your calculator very well. Sometimes you may not have time to start doing all this step by step. You may just need to, instead of not completing it, it may be better to just just jump two of these steps and get straight to the answer. But if you have all the time, it's better to go step by step like this. Okay. So, but if you don't have time, you can quickly just jump and move on. So this is 951.60.6 minus 121,498.8. That is given a negative value. That's minus 2.6, minus 263, so minus 26338.2 up there. So that means we are going to get a negative slope. So we have 42947, 429,474.84, 429,474.84 minus 347,864.04. So 429,474.84 minus 347,864.04. And that is 81610.8. Okay. Now, we go for the last step. So now you have beta 1 is approximately, of course, we have minus already there. That's a negative slope. We have 26338.2. 26338.2 divided by 81610.8. And that is minus 0.3227. Okay. So we have our answer for beta 1. Now, that's not the end. So that's beta 1. Okay, so here it's more like saying to find beta 1. That's what we have done now. We have found beta 1. So the next thing is to find beta naught. So to find beta naught, don't forget the formula for beta naught I already derived, which is this. Beta naught is y bar minus beta 1 x bar, right? Okay, y bar minus beta 1 x bar. Good. And how do we do that? We know that y bar is actually summation of y divided by n. And we already have all this. Summation of y is 589.8. So that's 589.8. 589.8 divided by 6. Oh, that's for x. Sorry. That's for x. That's for x, actually. So y bar is summation of y over n. So summation of y is 206. 206 divided by 6. N is 6, like we already knew. So that is 206 divided by 6. And that is approximately 34.33. Okay. That's y bar. Okay, let me make it 333 since everything is 4 decimal places. Then on the other hand, you have x bar, which is summation of x over n. Summation of x is 589.8 divided by 6 now, approximately. So summation of x, are we correct? Yeah, 589.8 divided by 6. So 589.8 divided by 6, and that is, okay, it's not even approximation per se. It's actually 98.3. Okay. So this is actually 98.3. So if that is the case, we can now have our equation. We can say, therefore, what's the question? Always answer the question in line with the original question. Always give your solution in line with the original question. So the table below, write the equation connecting x and y. Okay. All right. So you can say, therefore, the equation connecting X and Y is given by, okay, go again. You can go the long way, beta naught plus beta 1 X. So now you have, oh, okay. I think I'm in a hurry. I need to, the goal is to get beta naught and I've not got that. Okay. I'm really in a hurry. Okay. It's been a long. So these kind of questions, again, if you can avoid in an exam, please do avoid them. So we have that now. So beta naught is now equal to y bar, that's 34.3333. Okay, minus beta 1. Don't forget beta 1 is minus 0.3227. Okay, so that's minus 0.3227 multiplied by x, which is 98.3. So beta naught is equal to 34.3333. No, minus times minus is plus. Then we now have to multiply that again. This is 0.3227 times 98.3. 0.3227 times 98.3. That is 31.7214. Okay, 31.7214. So the beta naught now is 34.3333. Okay, plus 31.7214. 7214. Okay, and that is equal to 66.0547. So we can now go and say, therefore, the equation connecting x and y, is given as y equals beta naught plus beta 1 x. Okay, and that means, I mean, you can write it so that y now is equal to, what is beta naught again? Beta naught is 66.0547. We can make it two decimal places. That's like 66.05. And this other one can also be like that. That is minus 0.32. Minus 0.32. Okay. Okay. So beta naught now is 66.05. Then minus 0.32x. So this is the equation connecting x and y. This is the equation connecting x and y. So y is equal to 66.05. That's beta naught minus 0.32x. So it's a slope. So the relationship between x and y is actually negative. So it means that as x is increasing, y will be reducing because the slope is negative. So for every unit of x, y reduces by minus 0.32. That's what it means. Then when x is 0, y is 66.06. That's the interpretation of this. But we are not done yet. We have one tiny part to complete this. So the other part says, estimate y when x is 100. Estimate y when x is 100. Okay. So let's go for that. To estimate y, estimate y when x is equal to 100. So you invoke the equation again. Y is equal to y. Okay. Y is equal to 66.05 minus 0.32 x. That's what we have. So now you have y equals 66.05 minus 0.32 times 100. Okay. So that means that y is equal to 66.05 minus 32. 0.32 times 10 is 32. Times 100 rather is 32. Two decimal places. So you now have 66.05 minus 32. And that is y equals 34.05. So that is the value of y. So you can say, therefore, Therefore, when x is 100, y is y is y is equal to 34.05. And with that, we come to the end of this question. It's been a very lengthy one. If you can avoid it, by all means, please do that. If you don't have a choice, do it carefully. If you have not subscribed to this channel, you want to keep learning things like this. So you want to subscribe and hit the notification bell so you can always get alerted when a new video is released. Then comment. Tell me if you want me to treat a particular topic or solve a particular question, and then I can find time to do that. And then don't forget to like and share so that more people can have access to this great learning. Till I come your way again, keep crunching the numbers, keep solving the problems, and keep getting the A's. Bye.